4Z here. Welcome to From the Ham Shack. And we're here today up in my second floor ham shack, and we're going to talk about disconnecting your antennas. As you know, I live in South Carolina, and it is prime season for thunderstorms right now, middle of summer, and so we get pop-up popcorn variety thunderstorms quite often here in the South. And we get them in the spring, summer, and the early fall, winter. Very rarely do we see lightning, but it does happen occasionally. So my problem was my antennas were fed from the shack basically through the window behind me, and the cables ran out over the porch roof and kind of down to the foundation and out to the yard to go back up to the antennas. And the wife was not happy with the cables, and I wasn't either. It was aesthetically not too pleasing. So we were encouraged, or I was encouraged, to straighten the cables up and get them hidden. And so the way to do that was to go through my attic. I bought an MFJ window panel pass-through, and ran the cables up from the ground, or from the antennas around the house, up from the ground floor, which is crawl space, up past the first floor, past the second floor, and into the attic, and through the attic, across the attic, and back down into the ham shack. Now, that being said, I didn't have a good way of disconnecting the antennas coming into the house. I do have polyphasers on the antennas out at the feed points for those, where they junction up to the coax that comes in the house, but I don't want to have to go traipsing out in the yard every day to connect the cables up and then go disconnect them when I'm ready to quit playing radio. What was convenient is having the window behind me, as I could bring the cables in and connect the cables up, and then when I didn't want them, put the rubber boots on them, throw them back out the window, close the window, and I was done. Now, that was a pretty easy way of disconnecting the antennas. Now, it didn't really do much for me, bringing current to the house if we had a close by lightning striker, but at that point in time, if you're talking about a direct strike from lightning on your antennas, you're not going to protect much of anything, short of having a very large ground plane and being able to put all that power to ground. It's probably not in the realm of possibilities for most amateurs. And if you have got a tower, you might have a big enough grounding system. But for me, with a wire antenna, not so much. So lightning is so much power. You got to think it's bridging an air gap between the Earth and the clouds. Okay, so that's quite a bit of power. It's quite a big air gap for that thing that energy to go from the cloudy to Earth, or Earth to the cloud, whichever the strike may be. So you're not really going to survive a direct strike. You might, but chances are not very good. But a close by strike and stray static electricity, those kind of things, you want to prevent that from getting to your radios. Well, if you leave your antennas connected all the time, sure. And I've heard people putting mason jars and putting a rubber lid over the top of it and sticking the connectors down in there, and that works fine. But crawling underneath the desk to disconnect all the time, probably not an option for me. So I did some searching, and last fall actually I ran into N1ZZ, Dan Grevereau, and Dan was one of the guys that started West Mountain Radio. And Dan actually has another company now, and it's called Paradan Radio. And one of the products they provide is an antenna disconnector, and it's this lovely thing right here. So it is a water-resistant housing with a relay set of relays inside. Now he makes a single. This is the dual port. You've got SO239 connections from the radios to the antennas, and there's a couple of big high-powered relays in here, and some gas tube protectors, and ground. So in principle, the way this works is you apply 12 volts to this. It closes the relays and makes a connection from the antennas. When it's de-energized, the relays are in the open position, and they are actually at ground. So you would attach this port with some grounding wire, or braided, I like braided tin copper strapping, and to a ground rod, and that'll take the any kind of voltage or stray voltage you may have and translate it from the antennas down to ground. Now, that being said, you have to have DC power going out here. So Another item I have is a surge protector for DC power for 12 volts. So this little bad boy is basically a solid state diode, for lack of better terms, large diode that's going to protect my 12 volt line coming in from any surges coming from outside. So if we do have something that gets close to the house, I don't want it coming back on the antennas, and I don't want it coming back on that 12 volt lead. So if it comes on the antennas, it'll get grounded here. If it comes on or close enough to come onto the 12 volt lead, or try to jump the 12 volt lead from this box, then this little bad boy is going to stop that, and it goes to ground here via this pigtail. So that's, you know, the principle of it. Now, Dan, with these boxes, he gives you directions that you can put the DC power coming off the back of your radio through the accessory port when you switch it on, to feed that, and that way when you turn your radio on, your antennas are connected. It's a good solution. But for me, I have multiple radios, so I guess I could build a split circuit and have it come off both, but then you're talking about possibility of having voltage seep from one radio to the other radio. Probably not a good idea. The other option is you could feed it from your power supply, and when you turn the power supply on for your radios, it'll connect the antennas, and that's a fine solution as well. But I don't turn my power supplies off very often on the desk, because I've got a diamond antenna 60 amp power supply that powers a few other things here on the desk that are not radio related, so to speak. So I don't want to be switching that power supply on and off when I leave, because I may not be playing radio, I may be doing something else on the desk, and I need the 12 volts. So what I came up with is a switch box, and basically I have it built, and I've got it here on the desk, and so this is the switch box, and it's built to harness to control 3 of these units, or 3 single units, whatever you want to do, but 3 antenna disconnectors. I've got one out at the side yard now controlling the 2 HF antennas, and I have one that I've got here in the shack I just showed you that's going to be on the UHF antennas, UHF, VHF antennas on the other side of the house. So, but in concept, we've got a power main switch here, so when I click this on, it allows power to flow to these 3 switches, and then I can switch which of these disconnectors I want to turn on and off. On the back side, we got power pole ports. So I've got a main voltage in, DC power in. I've got HF 1 and 2, which is the box that's out at the side yard for the antennas, HF antennas, and then I'll put one for the UHF, VHF, and I'll have one spare at this point in time. The box has lighted LED switches. It's a really simple circuit to build. So let me put this back on the desk, and we'll show you basically some of the stuff with the circuit. The box itself is just a Amazon project box. Real nice little box, very cost effective, and it looks good. Now, I'm not crazy about the blue color, but I may end up painting it black at some point. And the labeling on there right now, I just have some temporary labels on there. My wife has a Cricut, and she's been gracious enough to offer to cut me some vinyl letters that'll go on there. It'll give it a nice finished look. So I don't know if I'm going to go with white or if I'm going to go black yet. Those decisions will be made a little bit down the road, but for right now, those vinyl labels suit my purpose. So we talk about the circuit here. You have the DC in, which is on the power poles. The red lead goes over to the top of the switch inside the box, and then off the bottom of that first switch, the main power switch, I feed the other 3 switches, and that gives us the ability to control power going to all 3 of those switches. And then the individual switches, when you close those switches, it turns or closes the circuit and allows current to flow to each of the individual 3 power pole connectors on the backside. Now, the negative side of the circuit, or the ground side of the circuit, whatever you want to call it, being that it's DC voltage, we'll call it the ground side of the negative side of the circuit. The negative side of the circuit, all those leads are all tied together. Now you can accomplish that through wire nuts. You can accomplish that through a bus bar. Basically, what I did is I made just a wiring harness, and using quarter inch disconnectors, and coupled all the wires together through those in a chain and made a wiring harness and put it together. Now we're going to have a video out on the construction of the box. It's a little bit long. It's about an hour long, and it takes you from basically the setup on the box through the construction of the box and the testing phase, and then a little bit about outside. So very simple circuit. And what I did when I was building this box is I went to I used Visio to do most of my work drawings and do all my engineering drawings, and sometimes in CAD, but mostly Visio. So I used Visio for this one, and this basically is the layout for all the 4 switches and the 2 power pole ports that are on the back of the unit. And I went ahead and designed it, laid all the ports out, and then I took that drawing and I went ahead and printed it on a piece of paper. It's to scale, and then I taped it to the plates that are on the front and back of the box. I center punched them, took them down to the garage, and I went ahead and used my drill press to drill out the holes. So made it very easy to put it in there, very quick work. Although my hole saw for the 1 3/16 hole for the back of power pole connectors was a little dull, so I actually had to go and get another one of those out of the tool drawer. So it took me just a few extra minutes to do that, but you know, it worked out great. Brought it up, assembled the box, put the box together, and it worked out fine. Now, the outside portion of this setup, if you want to see it, basically it's a DX Engineering DXE UE2P box, and it's a polycarbonate box. It's got a really nice aluminum backplate in it. It's a real nice kit. And I understand it's a 12 by 12 box, and it comes with a bunch of little accessories. And one of the accessories are the sealed nipples, so you can put the drill holes in the top of the box or side of the box and come in and feed in. Now, the way they show this box in the instructions is to use those sealed nipples and come in from the top of the box here and come out the bottom box. So the bottom box has really nice neoprene fingers in the bottom to allow you easy entrance, and you don't have to drill any holes. The problem I have with that is I don't care how good those waterproof nipples are, and I don't care how much you use of the mastic tape or the self-amalgamating tape, coax seal, whatever. Eventually that stuff's going to dry out. And if you come down and you put a vertical surface here, water's going to follow that vertical surface because it's going to follow gravity. And eventually it's going to work its way into the box. That's why I always like to enter either from the sides or the bottom preferably. So the problem I had is the disconnector itself is quite large, and this box is only 12 by 12. And you start talking about bend radius of the coax. And I was in a class, RF class, a while ago, and the instructor told us about bend radiuses that DBs do not have knees, so they don't like to go around the corner and they don't bend very easily. And what he's talking about is the insulation inside the coax. If you bend that too tightly, it changes the propagation properties of, or the transmission properties of that cable, and you can do some damage to it and it won't be as efficient. So we don't like to make tight bend radiuses on coax cable. So my solution for that was to go ahead and use, this is the inside of the picture, the inside of the box, go ahead and use the 90-degree connectors. Now, again, it's a little tight for 90-degree connectors. It would be better served if you were able to come up and loop over to these things. But the 90-degree connectors, basically, I've got one. The top ones are sitting out at a little bit of an angle to allow me to put the second one on the bottom. But all in all, it works fine. No issues, and I keep my bend radiuses at a minimum. And you can see I mounted the 12-volt surge suppressor there. Just got a double stick tape because there is no mounting hardware with that thing. There's no DIN rail, nothing. So went ahead and mounted that up. And then at the bottom here, you see the I've got the braid coming off the bottom port of the disconnector from the ground port. That comes through and underneath that copper bar, which grounds the whole plate. And then I did take the pigtail and run it underneath there as well to one of those screws. And then that piece of braided line runs out to an 8-foot ground rod that's driven in the ground right next to it. So I've got a pretty good grounding system on this. Now the circuit that is on this unit, pretty simple. You've got the control circuit down here, which basically allows power to either close or open those relays. The relays themselves, and then you've got the gas element protectors, so that if you get an overvoltage that gets past the relays, that gas element glass fuse element blows, and away we go. So it shuts your system down, and everything goes. It's all grounded to the chassis, and the chassis takes it to ground from there. But it's a pretty neat design. You could do the same thing with some high power relays and build it yourself. I don't know if it would be any cheaper. The dual disconnector is about $190. For me, it was very easy to have that in one piece, not have to mess around with it, and have everything know it's going to work without having to do too much legwork. So it was worth it for me to go to that. It's a very nice design, very elegant design, and was really pleased with it. Now, I do have the parts list. The parts list will be in the description. The box itself and the disconnector, everything that I use for this piece of the project to select the disconnectors was about $480. So not a cheap project, but a good one for what I was trying to accomplish. So let's take a look at what this thing actually does. I'm going to connect the box up. Let's switch back to the main view. Okay, I'm going to put the box back together here. My DC power in at the top here, and my antenna port, or my disconnector port at the bottom. And I put little boots on these things, as little boots for the power pole connectors, and I was not overly excited about that because the boots actually make it a little bit tough. So I'm going to switch over to screen 3 here, the flex screen, and I'm running a Flex 6400, and you can see up here I've got a little bit of signal coming in. I happen to know I have a neighbor close by that's an operator, and that's probably his signal. I had a landscaper cut a couple of the cables to the antennas last year, and I couldn't figure out what was going on because I was only getting one signal. It was K4VSV, my buddy Bill, and he lives about less than a mile, I guess, for this crow fly from here, and he runs enough power that I was actually getting him on just the coax cable laying in the yard. So I have a feeling that's probably him. But right now we've got power on the box, as you can see here, the lighted switch, and we're going to go ahead and switch the disconnector on, and lo and behold, we have signal. So you can see how much isolation that gives you. Again, a direct lightning strike, it's probably not going to do much, but when you're talking about static discharge, or a close by strike where you may have some residual static, it's probably going to work really, really well. So I'm really quite pleased with this project. It solved the problem for me. And again, if I flip this switch, away go the signals. So as you can see, it works really, really well. Dan built a quality product here, and I'm very pleased with it. So a couple different sources. Quicksilver radio for some of the small parts, the power pole connectors, the 90-degree turns, and a few other items. The Paradan came from, obviously, from Paradan radio, the antenna disconnector. The boxes came from The project box and the switches and a few other things came from Amazon. Some of the wire and the ground rod and a few other things came from Home Depot, and then the box itself from DX Engineering. And so I'd like to thank them for building a quality box too. The thing's exceptional. Just needs to be a little bigger, guys. Especially if you really think about the logic. You want a drip loop to not have a vertical surface to bring water into your box. So may want to rethink that, make it 18 by 18, and I think you'd be a winner product there. Even though it's not a bad product now, it does what it's supposed to do. Other than that, I think it's, you know, the wife's happy. The cables are, the unsightly cables off the front porch are gone. I'm not looking at them, and I have a way to disconnect. Now, if I'm gone out of town for 6, 7, 8 days on vacation or traveling for business and the radios aren't going to get used, yeah, I'm probably going to go outside and I'm probably going to do 2 disconnects. One at the polyphasers. I'll disconnect the feed line off the radio side of the polyphasers and then off the antenna side of the disconnector, and that'll allow me to have 2 places where I don't have any kind of connections in the antenna. So if I'm going to be gone for a long time, just to protect everything and make sure my peace of mind that I'm not looking at any kind of voltage getting into the house, save a direct lightning strike. So I hope this helped you solve a problem and maybe got you thinking about how to disconnect your antennas. And until we get to see each other again, and be looking for the production video on the box. Like I said, it's going to be a little bit longer. Should have that out this week. And again, be passionate about your radio. Enjoy your radio. We'll say 7-3, and this is NJ4Z out from the Ham Shack.